Hello everyone, I hope you all are doing good. Welcome back to my channel Chemist 243. Today we are going to learn about the polymer based supercapacitor. The reason for choosing this topic is that we are more into the energy storage devices because of the recent energy crisis all over the world. So without any delay, let's start our topic, that is polymer based supercapacitors. So first of all, we need to understand what basically the supercapacitors are. Supercapacitors, which are also known as ultracapacitors and also named as electrochemical capacitors. The name electrochemical occurs due to the electricity production and the chemical reactions that are occur inside the capacitors. These are the efficient energy storage devices and actually uh, bridge the gap between the traditional capacitors and the batteries. Traditional batteries include the lithium-ion batteries or sodium-ion batteries, but due to the poor cyclic stability and high prices, we are more into the supercapacitor, which are more efficient as compared to traditional batteries. They actually offer the high power density. They have great cyclic stability. They have rapid charging and discharging capabilities and long cycle life. Moreover, they do not have any environmental concerns, so these are more preferable. If we talk about the applications of supercapacitor, the applications are in energy harvesting. They are used in consumer electronics, and of course they are very useful at the industrial and transportation scale. You can see in the picture we have supercapacitors. Now, what basically the polymer based supercapacitors are? You need to understand we are merging the two different terminologies. The first one is the polymer and the second one is supercapacitor. So actually we are combining the effect of polymer and we are combining and merging the properties of polymer with a supercapacitor. We all know polymer are basically the macromolecules that are formed by combining these small units, and supercapacitors we already know are the efficient energy storage devices. So in this topic we will cover the effects and combining properties of polymer and supercapacitors and how the polymer based supercapacitor could be the new generation energy storage devices. So polymer-based supercapacitor are energy storage devices because they provide the high energy density and rapid charging and discharging capabilities. You need to understand that whenever we talk about the energy storage devices, actually we are talking about the different parameters, which include the electrochemical phenomena, the charging and discharging time, the movement of electrons, the control temperature pressure conditions, the reaction availability, the environmental concerns, and overall efficiency of given energy storage devices. The polymer-based supercapacitor are increasingly used in the application because they require a very quick energy burst, such as electrical vehicles and renewable energy system. So in modern world, we are more focusing toward the different types of supercapacitor, for example using polymer based supercapacitor because they provide a quick energy burst that are very useful in the electrical vehicles. Now, what are the properties of polymer based supercapacitors? The properties are very extensive. Some are explained as they got easy fabrication process. The methods are quite simple. They have high specific capacitance. They have high cyclic stability. The senses is quite easy because we can easily control the temperature and pressure conditions. The salt, the precursors are not much expensive, and they have, of course, great electrical conductivity. So They got excellent properties as compared to the lithium ion batteries or sodium ion batteries. So we are more focusing toward the polymer based supercapacitor, and which are also known as conducting polymer supercapacitor. These properties makes our supercapacitor are very efficient devices to be used for the next generation energy storage devices. So, what is the working principle behind the supercapacitors and energy storage devices? So, polymer based supercapacitors basically operate on the principle of electrostatic charges that accumulate on the surface, and they are also used to produce the pseudo capacitance. So, you need to focus on the term that is pseudo capacitance. We all know what basically the pseudo capacitance is. So basically, charge is stored at the interface between a conductive polymer and a given electrolyte. So actually, we are dealing with the dual mechanism, because this dual mechanism allows for the high energy storage as compared to the traditional capacitors. You can see in the picture the positive and negative charges alignment. We have electrodes, positive and negative, named as cathode and anode. We have a current collector, and of course the oppositely charged ions will be migrated toward their respective electrodes, and you can see the formula of capacitance, which basically directly proportional to the current produced and overall the charge density. Now, what are the basic components, or you can say the basic construction of our polymer based supercapacitor? First of all, we need to develop an electrode. So, electrode could be conductive polymer as active electrode material. Of course, all the reaction like charging, discharging, and accumulation take place at the surface. Second, we need an electrolyte. Electrolyte could be of liquid nature, could be of gel, could be of solid polymer like PEO, PAN, which basically combine with the lithium or any other ionic salt. Number three, we need a separator. Of course, separator is used to prevent the short circuit, and it is made up of glucose or any other polymer gel. So there are three main components of our polymer based supercapacitor. First of all, we need an electrode, we need an electrolyte, and of course a separator. So three important components for the production of polymer based supercapacitors. Okay, now how energy storage take place. We already learned about the introduction of polymer based supercapacitor. We learned their importance and what are the basic components. Now we are talking about the phenomena, actually how the energy gonna take place during this whole process. So the first of all, we have electrostatic double layer capacitance. Actually, it occurs at the electrode and electrolyte interface we already learned about. So it is the place where the charges are stored in the electric double layer, which is formed between the electrode surface and electrolyte. So we have electrode, we have an electrolyte. So between the electrode and electrolyte, there is a formation of double layer electrostatic capacitance. Number two, we have pseudocapacitance phenomena, which basically involve the redox reaction on the electrode material surface, or it can be occur within the bulk, which leading to the Faradic charge transfer and contribute to the overall capacitance. So when we talk about how the energy storage take place, actually we are dealing with the two phenomena. It could be occur due to the electrostatic double layer capacitance, and it could be results in the production of pseudocapacitance, which mainly involve the redox reactions. You can see the picture. In picture A, we are dealing with the electrostatic double layer capacitance. We have electrode here, we have electrolyte, and between electrode and electrolyte, accumulation of charges take place. There are three main components. You can see we already learned that We have electrode and we have separator and we have electrolyte. You can see the accumulation of positive and negative charges at their respective electrode, that is cathode and anode. So here we have anions and here we have cations because the separator is used to separate the opposite charges. In B picture, you can see a sort of redox reactions are taking place. That is, someone is going to be oxidized and other species going to be reduced, but still we have production of cations and anions. For right now, you can skip the phenomena of doping. Of course, doping is used to enhance the overall activity, but right now we are not concerned with the increased activity. We are actually just learning about how the charge accumulation take place. So picture A represent the electrostatic charge type, which leads to the double layer of charges accumulation, and the picture B represent the redox type reaction, which is also named as pseudo-capacitance. Now, what are the basic types of polymer-based supercapacitors? We have around about 5 different types of polymer-based supercapacitors. Now you can understand this phenomena is not very simple to understand. First of all, we have conducting polymer supercapacitors. We have conducting polymer supercapacitors like polyaniline, we have polypyrrole, and we have polythiophene. So these are the 3 different examples of conducting polymer. Actually, they include the high pseudo-capacitance because of the presence of redox reaction we already learned about. They typically exhibit the high energy density and they have good charging and discharging characteristics. They are used in the flexible electronics and the advanced energy systems. So these are the properties and some example of type number 1, that are conducting polymer supercapacitors. Number 2, we have composite polymer supercapacitors. It is basically the combination of conducting polymer in which the carbon based material are used. For example, we can use graphene, we can use carbon nanotubes or activated carbon. They actually show the enhanced performance due to synergistic effect of the component, because the properties of 2 components when combined, of course, they give an excellent result. They have improved conductivity and mechanical properties. So energy storage devices basically used in the advanced electronics, including the wearable technology. So we have learned about the 2 different type of polymer. The first one is conducting polymer supercapacitor like polyaniline, polypyrrole, or polythiophene, which are basically used for flexible electronics. However, the composite polymer supercapacitors are mainly used in the advanced electronics. Now we are moving toward the third type of polymer-based supercapacitor, that is electrolyte polymer supercapacitor. Polymer electrolytes, of course, they could be of solid or gel type. We already learned when we were talking about the component of polymer-based supercapacitor. They could be of PEO nature. We can use vinyl alcohol, which is mixed with any other ionic salts. These are very safe and stable, and they are used in the conjunction with conducting polymer. Once we have conducting polymer electrode, we can use, so they are often used in conjunction with the conducting polymer electrodes. They enhance the overall safety and reliability in supercapacitors application. They basically used in the portable electronics, electrical vehicles, and other areas which require a stable and safe energy storage. Then we have flexible polymer-based supercapacitors. Actually, these flexible conducting polymers or the composite material allow the supercapacitor to be easily bent or stretched. So they have high flexibility, just like a spring, which make them very suitable to be integration into any other flexible or variable electronics. They play an important role in the wearable technology, the flexible displays, and smart textiles. Then we have the fifth type, that is high temperature polymer supercapacitors. The polymers and electrolyte in this type are basically designed to operate at the elevated temperature. Of course, we can easily control the temperature condition. It involves the high temperature and stable conducting polymer. These type of polymers are very stable to operate in the harsh condition because they maintain the performance under the high temperature. They are basically useful in the aerospace, the automotives, and other high temperature environment. So these are the five basic types of polymer based supercapacitor. First of all is conducting polymer. The second one is composite polymer supercapacitor. The third one is electrolyte polymer supercapacitor, flexible polymer supercapacitor, and high temperature polymer supercapacitor. The best one is high temperature polymer. Of course, we are more toward the high temperature polymer because of their scalability and tunability, and we can control the given temperature condition. In picture, you can easily see the different type of capacitors. Some of them we already learned about. For example, this is the flexible electrode material. We have separator, we have metal wire, and it is the packaging plastic we see. We have already discussed the diagram A and B. The first one is regarding the accumulation of double layered charges, and the second one is regarding the redox reactions. In third one, we have different type of conducting polymers. We have used the material like RGO and RTIL to enhance the overall accumulation of charges and density. Now, what are the advantages of polymer based supercapacitor? Why we are just focusing more toward it? The reason is they are very flexible, they are lightweight, they are cost effective, they have high capacitance, and of course they are environmental friendly. So all these properties makes the polymer based supercapacitor an efficient energy storage devices or the next generation energy storage devices. Okay, lightweight. Conductive polymers are typically lighter than the traditional materials. You can see we have heavyweight batteries like lithium ion and sodium ion batteries, and they are difficult to carry. But the modern energy storage devices are more efficient and they are lightweight because they reduce the overall weight of the supercapacitors. The second one is cost effective. We all know that we are working on different projects that are not much expensive. Their precursors are pocket friendly. So this is one of the greatest benefit of the supercapacitor because they are cost effective. They actually lower the manufacturing cost because they have simple processing techniques, and the raw materials are abundantly available. The third one is environmental friendly. Of course, the energy storage devices they have some environmental concern, so we are more focused that the next generation energy storage devices should be environmentally friendly. Some conductive polymers they are less toxic and they are more environmentally as compared to the other heavy metals that were used in the conventional supercapacitors. Flexibility. The polymers can be easily processed into various shapes, the forms, which making them ideal for flexible and variable electronics. We already learned about the different type of polymer, and almost all of them are very flexible, so they can easily can be converted into different types. High capacitance. Polymers offer the high specific capacitance because they have ability to undergo the redox reaction. Not only the redox reaction, but they have also the phenomena of accumulation of double layer charges, which contribute to the high energy storage capacity. So these are properties like the flexibility, the lightweight, environment friendly, the cost effectiveness, and the overall high capacitance makes the polymer based supercapacitor different from any other energy storage devices. Now, what are the application? We can use them in the wearable electronics because they are very flexible, they are lightweight, so they can be easily integrated into the clothing or any other accessories. Portable devices, you can just pick them up, you can take them with yourself anywhere you want to go. They basically used in the smartphones, the tablets, and any other portable devices like smartwatch because they require a quick charging and discharging, easy to carry. So, emergently used as the portable devices. Number three, they are very useful in energy harvesting because they are paired with the renewable energy sources like the solar panels. So of course they are playing best role in the energy harvesting. Then we have electric vehicle. They are using regenerative braking system, which is a supplementary power. If we need a quick energy burst or we need to quickly stop the given vehicle, so they are using a regenerative, a different type of braking system. Any other application involved, they are widely used in the electrical vehicles. We all know the regenerative braking system and the overall acceleration support. They are also employed in the renewable energy devices because they smooth out the given energy supply and avoid any fluctuations in the energy. Other applications include the consumer electronics, the backup power supplies, and portable devices. But this is not the end. These are not only the uh, like few application of the polymer based supercapacitors. Of course, the application are very versatile and huge and vast. We are just discussing the important one that are in line. They could be used in the wearable electronics. They are used in the portable devices. They could be used in the energy harvesting, energy vehicles, and some modern applications like provision of energy without any fluctuations, regenerative braking system, the acceleration support, and many other applications like the backup power supply, and of course the lightweight portable devices. Okay, so this is one of the emerging use of the polymer-based supercapacitor in the military and aerospace. We already learned the high temperature conductive polymer are very flexible in nature, so they can turn easily into different shapes and they can accept the different temperature range. So UAVs stands for the unmanned aerial vehicles, which enhance the overall performance of UAVs and drones because they provide a very lightweight and efficient energy storage system. Many portable military equipment are dependent on the polymer-based supercapacitor because powering the portable military equipment and communication devices, it requires a very reliable and high power energy sources. So they are dependent on the polymer-based supercapacitor because they provide a quick energy burst for the different portable military equipments. They are used in the medical devices. For example, they power the implantable medical devices such as pacemakers, the neural stimulators, because they're very flexible and their biocompatibility is very good. They are used in the different portable medical equipment because they enhance the overall performance of the portable medical equipment, such as defibrillators and diagnostic tools. So, military and aerospace and medical devices are the new branches in which the polymer based supercapacitors are really playing an important part. No matter how efficient the polymer based supercapacitor are, or no matter how much they are toward the emerging energy storage devices, we also have some challenges. The challenges are regarding to the stability, the conductivity, and the overall electrochemical performance. So let's look at the different challenges. The first one is stability. Of course, the conductive polymer can easily be degraded over the time. For example, if we are using them in the harsh operating condition, their performance will be reduced and lifespan also will be decreased. So we have challenge regarding the stability of polymer based supercapacitor. The second one is conductivity. The polymers are conductive and they're generally less conductive as compared to the metal precursor or iron we use in the different carbon based nanomaterials, which limit the overall performance of the supercapacitors. So we have challenge regarding the conductivity because as compared to the metals and carbon based material, they are less conductive in nature. Third challenge we face is the electrochemical performance. Balancing the trade-off between the high capacitance and long cycle. Look, we are dealing with the two different things. We want a high capacitance and a good cyclic stability. So we need to balance the two factors, the high capacitance and the long life cycle. And it is very significant challenge in the overall development of polymer-based supercapacitors. So no matter how efficient they are, we still need to think about the challenges that are regarding the stability, the conductivity, and the overall electrochemical performance of the polymer-based supercapacitors. Okay, so what are the recent developments regarding the challenges or any other application of the new technology in this era? So researchers are basically working on the hybrid system. We already know hybrid means two or more things will be combined together, and of course they will produce a synergistic effect. So scientists and researchers are more focusing toward the hybrid energy storage system because it will combine the polymer with any other material. It could be like graphene or carbon based or other metals, which will enhance the overall performance. The researchers are also making advancement in the nanostructuring techniques. They are more focused toward the recent development of the nanostructuring technique because they will enhance the overall surface area, so there will be easily charge accumulation at the electrolyte and electrode surface, and of course it will enhance the overall conductivity of the polymer based electrode. The scientists are also working on the development of environmental friendly and more sustainable polymer that could be used in the harsh conditions. So in the recent development, the polymer-based supercapacitors are being integrated with the other renewable energy systems, such as they could be used in combination with the solar cells, with the wind turbines, because they provide an efficient energy storage solution. So this integration, like the addition of polymer to the other renewable energy storage system, aims to enhance the overall stability and reliability of the renewable energy sources. Moreover, it will enhance the overall the conductive power of the polymer based supercapacitor, and of course it will be very helpful to cope up with the challenges we are facing right now with the stability and other conductive power of the capacitors. Efforts are being made to increase the overall energy density of the polymer based supercapacitor because it includes the designing of the novel electrode material. Of course, we have also worked on the different electrode materials so we can bestly accumulate the charges on them, but still more research is going on the novel electrode material which can optimize the given nanostructures of the polymer to enhance the overall energy storage capability. So we are not just stop on coping up the challenges regarding the stability or any other challenges we are facing regarding the capacitors. Many future trends are on the way to deal with all the uh, problems and working on their solution. So, what are the future trends? The future trends regarding the polymer based supercapacitor is the integration of this capacitor with the other energy harvesting technologies, which of course expected to increase their applicability. Research is ongoing which aim to develop the more efficient material that would lead to the high energy density. We are more focused toward the electronics that are more likely to drive the innovation in a given flexible way, and they can produce a more compact supercapacitor design. So our future trends are basically more toward the energy harvesting technologies and to develop a more efficient material to produce the high energy density. What is the comparison with the other energy storage technologies? Of course, the energy storage technologies are somehow useful in many other way. So how we can compare the different energy storage devices to check their efficiency? So polymer based supercapacitor provide the faster charging and discharging cycle as compared to the traditional batteries. They have a longer life cycle as compared to the conventional capacitors, but their energy density is somehow minimum than the lithium ion battery. We already learned about the other metals and carbon based materials have high energy density as compared to the polymer based supercapacitors. So we need to understand the application first, and then we need to work on the electrode and electrolyte material to cope up the problem and to choose the right energy storage solution for our given problem. So here is the conclusion. Uh, we are talking about the polymer based supercapacitor, but this is not the end. Of course, the research is going on to cope up all the problem. So polymer based supercapacitor represent a very promising frontier in the energy storage technologies. What makes them unique? We already know they have good cyclic stability, they have greater charge density. They are very flexible, they are lightweight, they are cost effective, they have less environmental concern. So these are unique properties actually make the polymer based supercapacitor very suitable for the various high demand applications. The research and development is continue, which basically enhance the overall performance for the future energy systems. So that's all for today. Thank you so much. If you like the content, you can simply show your like, and we will continue our series with the more interesting topics. These topics are very important to give information about the recent trends in the energy efficiency, what are the challenges, and how we can play a role in the given energy crisis. So polymer based supercapacitor is one of them. um, they are very helpful in coping up the overall energy crisis to some extent. Of course, scientists are working to cope up with their problems and giving the solution, but still they are very helpful in the modern technology. So that's all for today. Take care. Thank you so much.